associative property. The associative property states that when adding or multiplying a series of numbers, it does not matter how the terms are ordered. Remember that simplifying within the parentheses is the first step using the order of operations. So you can remember the associative property, the rule for the associative property, because the numbers are grouped or associated with one another. Let's look at a couple of examples. A plus B plus C is equal to A plus B plus C. So again, we're going to do what's in the parentheses first. Let's try this with 2 plus 3 plus 4 equals 2 plus 3 plus 4. So again, we're going to follow our order of operations, or PEMDAS. We're going to start by adding 2 plus 3, 5 plus 4 is equal to 2 plus, and again, following order of operations, 3 plus 4, which is 7. 5 plus 4 is 9, and that does equal 2 plus 7, which is also 9. So you can see it doesn't matter which terms we add first. Since we're doing addition, it doesn't matter what we do first. Let's see what happens when we do the multiplication side. So again, I'm going to use 2 times 3 times 4 is equal to 2 times 3 times 4. According to PEMDAS, we have to start inside our parentheses. So that's 2 times 3 times 4 is 12 is equal to, again, starting in our parentheses, 2 times 3 is 6 times 4. 2 times 12 is 24, and that does equal 6 times 4, which is also 24. Like the commutative property, the associative property is only true for addition and multiplication. Let's look what happens when we try to use it on subtraction and division. So if we tried to use the associative property, it would look like A minus B minus C, but again, it's not going to be equal to A minus B minus C. So I'm going to use numbers like 8 minus 4 minus 2 does not equal 8 minus 4 minus 2. Again, using order of operations, 8 minus 4 is 4, minus 2 does not equal 8 minus 4 minus 2 is 2. 4 minus 2 is 2, and that does not equal 8 minus 2, which is 6. As you can see, the associative property does not work on subtraction. Let's use it on division now. So with division, it would look like A divided by B divided by C, again, will not equal A divided by B divided by C. I'm going to use the same numbers we used for subtraction. So 8 divided by 4 divided by 2 does not equal 8 divided by 4 divided by 2. Let's simplify. Order of operations, 8 divided by 4 must be done first. 2 divided by 2 does not equal, again, parentheses first, 8 divided by 4 divided by 2 is 2. 2 divided by 2 is 1, and that does not equal 8 divided by 2, which is 4. And that's the associative property. Factors. Factors are numbers that are multiplied together to obtain a product. For instance, in 2 times 3 equals 6, 2 and 3 are the factors. common factor, a number that divides exactly into two or more other numbers. For example, the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 15 are 1 times 15 and 3 times 5. So the factors of 15 are 1, 3, 5, and 15. The common factors are 1 and 3. Those are the factors they have in common. Prime number. Prime numbers have two distinct, which means different, factors. 1 and itself. The very first prime number is 2. Because the only numbers, the only factors of 2 are 1 and 2. 1 times 2 is 2. Some people think that 1 would be the first prime number. But 1 only has one factor. 1. 1 times 1 is 1. So 1 is commonly thought of as neither prime nor composite. A composite number being a number that has more than 2 factors. So 2 would be the first prime number, then 3, because 3 has only 2 factors. 1 times 3 is 3. 4 would be composite, since 1 times 4 is 4, and also 2 times 2 is 4. 5 would be prime. Its only factors are 1 and 5. 6 would be composite. 1 times 6 is 6, and 2 times 3 is 6. 7 would be prime, since its only factors are 1 and 7. 8 would be composite. 1 times 8 is 8, 2 times 4 is 8. 9 would also be composite. 1 times 9 is 9, 3 times 3 is 9. 10 would also be composite. 1 times 10 is 10, 2 times 5 is 10. 11 would be prime. 1 times 11 is 11. And so on and so forth. There are an infinite number of primes. A prime factor is a factor that's prime. So in our example above, in 12 and 15, the prime factor of 12 would be 2 and 3, and the prime factors of 15 would be 3 and 5. You can also do prime factorization. The prime factorization of a number, for instance, the prime factorization of 12 would be 2 times 2 times 3. That's where you write the product of a number only using primes. And the prime factorization of 15 would be 3 times 5. Unlike just writing the factors of a number, with prime factorization, you use only prime numbers as factors to multiply to get the result of the product you are seeking. Rates and unit rates. Ratios are considered rates when they compare two different units, like miles per hour or cost per ounce. A unit rate is one in which the numerator of the fraction is compared to a denominator of 1 unit. That way you can tell, for instance, like how much just 1 ounce of something costs. And you'll see unit rates a lot at the grocery store under or next to the price of an item. It'll tell you how much that item costs for every 1 ounce or for every one thing in the package. So let's look at a problem dealing with rates and unit rates. Dave is driving 240 miles to his aunt and uncle's house. If he gets there in 4 hours, how many, and here's the key right here in the question, how many miles per hour did he drive on average? In that question, they're telling you how to set up the problem. They're telling you to put miles over hours. So we're going to start with that. Miles per hour. And now we can substitute the information in from the problem. So they told us how many miles. He's going 240 miles. And they told us how many hours. 4 hours. So we can put that into our rate, 240 miles for his 4 hours. So right now this would be considered a rate since we have two different units, our miles and our hours. But to determine our unit rate or to figure out his average, we would need to divide or simplify our rate to find our unit rate. So if we want to have a denominator of 1, then we're going to have to divide 4 by 4 to get our 1. And if we divide our denominator by 4, then we must also divide our numerator by 4. 240 divided by 4 is 60. So again, this is miles per hour. So what this unit rate tells us is that on average he was going 60 miles for every 1 hour. So your answer could be written as 60 miles per hour is how fast Dave was going on average. Converting improper fractions to mixed numbers. To convert an improper fraction to a mixed number, first we're going to divide our numerator by our denominator. 22 divided by 5 is 4, with a remainder of 2. 4 is our whole number, while 2 is the numerator of our fraction, and the denominator stays the same. So 22/5 as a mixed number is 4 and 2/5. Let's look at one more. Again, to change an improper fraction to a mixed number, we're going to start by dividing our numerator by our denominator. 18 divided by 4 is 4. 4 times 4 is 16, so we have a remainder of 2. 4 goes into 18 4 times with a remainder of 2 out of 4, since our denominator stays the same. This mixed number is special because we can simplify this fraction 2/4, and when you can simplify, you always want to do that. So 4 and 2/4 simplified would be 4 and 1/2. Since the GCF of 2 and 4 is 2, we divide both numerator and denominator by 2. 2 by 2 is 1, and 4 divided by 2 is 2. So 18/4 as a mixed number is 4 and 1/2. Adding and subtracting fractions. To add and subtract fractions, first make sure that the denominators are the same. If they aren't, like in 5/9 minus 1/6, then we need to find the least common denominator. The least common multiple of 9 and 6 can be found by listing the multiples 9, 18, 27, etc. 6, 12, 18. Our least common multiple is 18, so we're going to change both of our fractions, 5/9 to something over 18, and 1/6 to something over 18. 9 times 2 is 18. So since we multiplied our denominator times 2, we must also multiply our numerator times 2. 5 times 2 is 10. 6 times 3 is 18. So we must also multiply our numerator times 3, and we get 3/18. So that means that 5/9 minus 1/6 is equal to 10/18 minus 3/18. Now we just subtract our numerators and put that difference over our denominator of 18. 10 minus 3 is 7. Then, if you can simplify the result, you should. But in this case, 7/18 cannot be simplified, so that's our answer. Let's look at an addition problem. Again, we've got to see if our denominators are the same, and if they aren't, then we need to change them so that they are. So we're going to find the least common denominator for 3 and 5, which means we're finding the least common multiple for 3 and 5. So I'll list the multiples: 3, 6, 9, 12, 15. And my multiples for 5, 10, 15. So my least common multiple is 15, which means I'm going to change both my denominators to something over 15. 2/3 equals something over 15. And 4/5 equals something over 15. So to get from 3 to 15, we have to multiply times 5. So we need to do the same to our numerator. 2 times 5 is 10. 5 to 15, we have to multiply 5 times 3. So we do the same to our numerator. 4 times 3 is 12, which means that 2/3 plus 4/5 is the same as 10/15 plus 12/15. And again, we add the numerators and put that result over our denominator. 10 plus 12 is 22. And this is an improper fraction since our numerator is larger than our denominator, so we'd want to change it to a mixed number. To change this improper fraction to a mixed number, we're going to divide our numerator by our denominator. 22 divided by 15 is 1, since 15 goes into 22 one time, with 7 left over out of, and the denominator stays the same. So 1 and 7/15 is our result. Multiplying and dividing fractions. To multiply two fractions, simply multiply the numerators and multiply the denominators. 3 times 2 is 6, and 4 times 5 is 20. Then we can simplify. 6 and 20 are both divisible by 2. So divide your numerator by 2 and the denominator by 2. 6 divided by 2 is 3, and 20 divided by 2 is 10. So 3/4 times 2/5 is 3/10. Now there is somewhat of a trick or a shortcut when multiplying fractions, so I'll show you that. 3/4 times 2/5. When you're multiplying fractions, before you multiply, look and see if you can cross cancel. When you're cross canceling, you're looking at a numerator and a denominator. So 3 and 5, if we look at 3 and 5, there's nothing we could divide both of those by. However, you could divide 2 and 4 both by 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. Then you multiply like normal. 3 times 1 is 3, and 2 times 5 is 10. So cross-canceling saves you the step of simplifying, but you get the same result. Make sure that you don't ever try and cross-cancel numerators with each other. It's only those diagonal numbers that you can cross-cancel. So you cross-cancel a numerator with a denominator. Now let's look at division. We're going to divide 2/3 by 3/4. And you know what's funny about dividing fractions is that you don't. We don't divide fractions. Instead, we copy the first fraction, we change division into multiplication, and we flip our last fraction. So we copy the first 2/3, we change division into multiplication, and we flip the last fraction over. So it's now 4/3. And now we multiply like normal. 2 times 4 is 8, and 3 times 3 is 9. And that can't be simplified, so 8/9 is our answer. When dividing fractions, just remember CCF. Copy the first fraction exactly as it is, change division to multiplication, and flip the last fraction. Decimals. Decimals use place value to represent an amount. To read a decimal, like we have here, first read the number to the left as a whole number, followed by and, then read the number to the right of the decimal, followed by the last place value. So this number would be read as 641 and 5,129 10,000ths. This number could also be represented as a mixed number. 641 and 5,129 10,000ths. Let's look at another decimal. 5 and 8,139 10,000ths. We could write this number as an improper fraction by taking the 5 plus, this would be 8/10ths since it's in the tenths place, plus 1/100ths, plus 3,000ths, plus 9 10,000ths, which would give us 58,139 10,000ths. So we've seen a decimal in decimal form. We've seen it represented as a mixed number and also as an improper fraction. Adding and subtracting decimals. When adding and subtracting decimals, first line up the decimals. We have 4 and 23 hundredths plus 9 and 75 thousandths. Same with subtraction. 5 and 629 thousandths minus 45 hundredths. Then if you have any empty spaces, you can fill in with zeros. Adding zeros to the back of your number, to the back of a decimal, doesn't change the value of your number. So these numbers are still what they were. They're still equal. And then we just add or subtract like we usually would. 0 plus 5 is 5. 3 plus 7 is 10. So write your 0, carry your 1. 1 plus 2 is 3, plus 0 is 3. Bring that decimal down. 4 plus 9 is 13. So our answer, or our sum, is 13 and 305 thousandths. Now for subtraction. We're going to do the same thing, except now we're subtracting. 9 minus 0 is 9. 2 minus 5. We can't take 5 from 2, so we need to borrow from our 6, just like we usually would, and add a 1 onto our 2, which makes 12. 12 minus 5 is 7. And then 5 minus 4 is 1. We bring our decimal down. And 5 minus 0 is 5. So our result, or our difference, is 5 and 179 thousandths. Dividing decimals. To divide decimals, first move the decimal point in the divisor so that it's a whole number. Then move the decimal point in the dividend the same number of places. And finally, move the decimal point up so that you know where it goes in your answer. So this means that now we're dividing 25 into 789 and 5/10. Now we just divide as we would with whole numbers until we get no remainder, or you know it's a repeating decimal. So 25 goes into 78 3 times. 25 times 3 is 75. We subtract and we get 3. Bring down the 9. And 25 goes into 39 1 time. 25 times 1 is 25. We subtract. 9 minus 5 is 4. 3 minus 2 is 1. Then we bring down our 5. 25 goes into 145 5 times. 25 times 5 is 125. Then we subtract. 5 minus 5 is 0. 4 minus 2 is 2. And then we have to add on a 0 so that we can continue. Since our remainder isn't 0, we still have 20 here. We need to add on a 0 to bring down, because we can add as many zeros after our decimal place as we like without changing the number. 25 goes into 200 8 times. 25 times 8 is 200, so that when we subtract, we get a remainder of 0. Now that we've reached a remainder of 0, we're finished dividing, and our result is 31 and 58 hundredths. Multiplying decimals. When multiplying decimals, instead of lining up the decimal point, we line up the last digits on the right. So if we were multiplying 4 and 23/100ths times 9 and 75,000ths, we'd want to line up our last digits. So 3 is the last digit in 4 and 23/100ths, and 5 is the last digit in 9 and 75,000ths. There's my 7, my 0, my decimal, and 9. Now we multiply just like we multiply whole numbers. So starting with 5, 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus 1 is 11, carry the 1. 5 times 4 is 20, plus 1 is 21. And then I'll get rid of these. For our next number, now that we're multiplying times the 7, we need a 0 placeholder. 7 times 3 is 21. Write your 1, carry your 2. 7 times 2 is 14, plus 2 is 16. Write your 6, carry your 1. 7 times 4 is 28, plus 1 is 29. Get rid of those. Then we need 2 zeros for placeholders. And when we multiply times 0, 0 times 3 is 0, 0 times 2 is 0, and 0 times 4 is 0. We just get a line of zeros. So moving on to our last digit, now we need 3 0 placeholders before we multiply times 9. 9 times 3 is 27. Write the 7, carry the 2. 9 times 2 is 18, plus 2 is 20. Write the 0, carry the 2. 9 times 4 is 36, plus 2 is 38. Then just like we would with any other whole numbers, we're going to add our results together. 5 plus all these zeros gives us 5. 1 plus 1 is 2. 1 plus 6 is 7. 2 plus 9 is 11. Plus 7 is 18. Write our 8. Carry our 1. 1 plus 2 is 3. And then we have 8 and our 3. To determine where the decimal point goes when you've multiplied your decimals together, we're going to take how many numbers there were behind our decimal in our first number and how many numbers there were behind our decimal in our second number and add those together. So since we had 2 numbers behind the decimal here and 3 numbers behind the decimal here, then our result will have 5 numbers behind the decimal. 2 plus 3 is 5. 1, 2, 3, 4, 5. So this is the result of multiplying my 2 decimals together.
One of the most basic concepts in algebra is the single variable equation. A single variable equation consists of a variable, usually x, and some other numbers, and all you have to do to solve it is isolate x on one side of the equation by performing the same operations to both sides of the equation. So let's look at some examples here. In this first one we have x plus 13 equals 25 minus 19. So to isolate x, we need to get this 13 to the other side of the equation. To do that, we need to subtract 13 from both sides of the equation. So this will cancel, and what we're left with is x equals 25 minus 19 minus 13. And so now all we have to do is solve this part over here, and we've got the value of x. So let's do these one at a time. X equals 25 minus 19 is 6. So x equals 6 minus 13. And 6 minus 13 equals negative 7. So in this equation, x equals negative 7. In the second example, we have 10 minus x plus 38 equals 54 minus 17. Now, in this equation, we have a negative x, so the first thing we want to do is get x to be positive. So to do that, we can add x to both sides of the equation, and that'll give us 10 plus 38 equals 54 minus 17 plus x. Okay, the next step is going to be to move these numbers over to this side so that x is over there by itself. So we need to subtract 54 from both sides and add 17. So what we have now is x equals 10 plus 38 minus 54 plus 17. And so once again, we'll just do these one at a time. 10 plus 38 is 48. 48 minus 54 is negative 6. And negative 6 plus 17 is 11. So in this equation, x equals 11.
Computation with percentages. In problems involving percentages, it is usually easiest to convert to a fraction or a decimal. Let's look at two examples. First, we're going to calculate 40% of 62. Of in math means to multiply. So we're doing 40% times 62. So now we need to convert 40% either to a fraction or to a decimal. I'm going to convert it to a decimal. And to do that, all I have to do is take my decimal and move it 2 places to the left. So 40% as a decimal is 4/10 or 40/100 times 62. 4/10 times 62 is 24 and 8/10. So 40% of 62 is 24 and 8/10. You can use mental math to find percentages, and on this one what we could do is find 10% of 62 first and then multiply that times 4, since 10% times 4 would be our 40% of 62. So to find 10% of 62, we would just move the decimal 1 place to the left, so that would be 6 2/10. And then we want to do that 4 times, so we just multiply that times 4. So 6 2/10 times 4, which would again give us 24 and 8/10. And this you could do a little easier in your head. Let's look at one more. Oftentimes, percentages are used to calculate the tip when you go out to eat at a restaurant. So here we're going to calculate a 20% tip on a $28.75 meal. So we want to know what is 20% of $28.75, since that's how much we need to leave them. 20% of how much our total bill was. So again, of is multiplication, and we want to convert our percent to a decimal. So move it 2 places to the left. So we're really doing 2/10 times $28.75. And 2/10 times $28.75 is $5.75. So we would need to leave them a $5.75 tip. What would our total bill be? Well, our total bill would be how much our food costs plus how much we're leaving in a tip. So $28.75 plus $5.75. 5 plus 5 is 10. Write your 0, carry your 1. 7 plus 7 is 14. Plus 1 is 15. carry your 1, bring down our decimal. 8 plus 1 is 9, plus 5 is 14. Write your 4, carry your 1. 2 plus 1 is 3. So our total bill would be $34.50 with the tip included.
An equation consists of two mathematical expressions separated by an equal sign. So for instance, we might have an equation that says 1 plus 1 equals 2. And this is true because this value is the same as that value. Now the beauty of equations is that you can perform any operations the same way on both sides of the equation, and the equation remains true. So for instance, we can add 5 to both sides of this equation, and the equation is still true. We can multiply both sides of the equation by 7, and the equation is still true. We can divide both sides of the equation by 13, and this equation is still true. And so anything you perform on both sides of the equation equally do not invalidate the equation. Similar to equations, we have what's called an inequality. So we might have the inequality 1 is less than 2. And so this consists of a mathematical expression on one side and a mathematical expression on the other side, and a sign that indicates which side is greater or lesser. So that's what we have here. This is read as 1 is less than 2. And similar to equations, we can perform the same operations on both sides of the inequality sign, and it can remain true. So again, we can add 5 to both sides, and it's still true. 6 is still less than 7. We can multiply both sides by 7, and it's still true. This side is now 42, and this one is equal to 49, so it's still true. And we could divide it by 13, and it's still true. The one thing that we can't do with inequalities without changing them that we can with equations is multiplying or dividing by a negative number. So if we wanted to multiply both sides of this inequality by -1, that would make it untrue. Because in the most simple of examples, if we have an equation that says 1 is less than 2, and we multiply both sides by -1, that becomes -1 is less than -2, which is not true. So what you have to do, if you multiply or divide both sides of an inequality by a negative number, what you have to do is reverse the inequality sign. And so this is now a valid inequality once again, because we switched this sign after multiplying by -1. To show in real simple terms what that looks like, if you have 1 is less than 2, and then you want to make it negative, you can say -1 now is greater than -2. And that is the true expression of the inequality. And so you can have greater than or less than, and you can also have a greater than or equal to, which is something of a combination of equations and inequalities. So we would write greater than or equal to as a greater than sign with a line under it. And similarly, less than or equal to would be less than with a line under it. And so this is kind of a more formal definition of equations and inequalities and what you can do with them.
Linear equations. Marielle has 10 coins in her pocket. All of them are quarters and dimes, and their total value is $1.60. How many of each type of coin does she have? We can solve this by using a system of equations. We're told that she has 10 coins in her pocket and that they're all quarters and dimes. So if we use D for the number of dimes, and Q for the number of quarters, then one of our equations could be her number of dimes plus her number of quarters is 10 total coins. Next, we're told that the total value is $1.60. Well, dimes are worth 10 cents. So 10 times however many dimes she has, plus quarters are worth 25 cents, so 25 times however many quarters she has will give us a total of 160. We've eliminated the decimals, so we just move the decimal over 2 times to the right for all of our numbers. So instead of 10 cents, we have 10. Instead of 25 cents, we have 25. And instead of $1.60, we have 160. But you could leave the decimals in there if you wanted to. Now to solve this system, we've got 3 options. We could graph both of these and see where they intersect. We could use substitution or elimination. And it's your choice. For this particular problem, I'm going to use substitution. So I'm going to solve for D in my first equation so I can substitute it in my second equation. So D is equal to, and I have to subtract Q from both sides, so negative Q plus 10. To solve for D, subtract Q from both sides, and you get negative Q plus 10. So in my second equation, I'm going to use negative Q plus 10 to substitute for D. So we have 10 times the quantity instead of D, negative Q plus 10, plus 25Q is equal to 160. Now we can solve for Q. To do that, first we need to distribute. 10 times negative Q is negative 10Q. 10 times 10 is 100, so plus 100, plus 25Q equals 160. Now to solve for Q, we need to combine like terms. Negative 10Q plus 25Q is 15Q, plus 100 is equal to 160. Subtract 100 from both sides, and we get that 15Q is equal to 60. Now we divide both sides by 15. 15 divided by 15 is 1, and 1 times Q is just Q. We get that Q is 4, which means she has 4 quarters. So how many dimes does she have? Well, we know that her number of dimes is equal to negative Q, so negative 4, plus 10. So her number of dimes is negative 4 plus 10, 6. So we can say Marielle has 4 quarters and 6 dimes in her pocket. Word problems and addition. Solving word problems is made easier if you know what certain words mean. For instance, here we have a list of words that all indicate addition. So if when you're reading a word problem, you see more than, increased by, some, total, or in all, then chances are you're going to be adding something together. Let's look at an example. 2 more than a number is 15. What is the number? The first thing I'm going to do is translate these words into a mathematical sentence. So 2, I'm going to write the number 2. More than, I know, tells me to add. When it says a number, well, that's something I don't know. What number is it? And so if it's something I don't know, then I can put a variable there, like an X or a Y, or really anything you want to use. Is in math means equals, and then equals 15. So the only kind of trick here is that more than tells you to reverse the order. It's not just addition. It means instead of doing 2 plus x, I'm really doing x plus 2 equals 15. So now you can probably just look at this and see what number you would have to add to get 15. And that number would be 13, which means x is 13. If you don't know by looking at it what the answer is, then you can solve it algebraically here by subtracting 2 from both sides. But again, you would get that your number is 13. Word problems and division. Here we have a list of some words that indicate division. So if you're trying to solve a word problem and you come across the word quotient, per, out of, or ratio, you'll know that you need to divide something. Let's look at an example. If the quotient, there's one of our key words, of a number and 10 is 3/5, what is the number? So again, we saw that keyword quotient, which tells us we're going to be dividing something. We're going to be dividing two numbers. And those numbers we're dividing are a number and 10. And they must be divided in that order. So when we write our division problem, we could write it as x divided by 10, or we could write it as x divided by 10. But it must be in that order. If we reverse it to do 10 divided by x, then that is not what is written here in this problem. That would be if the quotient of 10 and a number. So order is very important. Since it was written if the quotient of a number and 10, then we must have that number first divided by 10. And you'll see here that I put x, and I put an x because we don't know that number. It just said a number. So when we don't know a number, we use a variable in place of that. Let's finish the sentence. If the quotient of a number and 10 is 3/5, is equals 3/5. Now, since I chose to write it this way, x divided by 10 equals 3 divided by 5, it looks like a proportion, and that's because it is one. All a proportion is a ratio equal to a ratio, and that's what I have here. So to solve this proportion, we're going to cross multiply. X times 5 is 5x, and that's equal to 3 times 10, which is 30. And now we need to solve for x. This is 5 times x, and the opposite of multiplying is dividing. So we divide both sides by 5. 5 divided by 5 is 1. 1 times x is x, and that equals 30 divided by 5, which is 6. So the quotient of 6 and 10 is 3/5. And that's true. 6/10 does simplify to be 3/5. Word problems and multiplication. When you come across a word problem that has any of these words, product, times, twice, or of, chances are you're going to have to multiply. Now this is not a comprehensive list of all of the words that would tell you to multiply, but this is a few of them. Let's look at an example. If Marianne opens a bank account with $450 and earns 12% in interest each month, what will her total balance be at the end of the first month? So what they're asking us to find is our total balance. Since I don't know the total balance, then I'm going to have to use a variable for that. So let's say T then is going to be our total balance. And in order to find my total balance, I'm going to have to take what she's starting out with, her $450, and the amount that she earns in interest in that month. So my total balance will be found by taking the starting value and adding the interest to find my total balance. So to find my total balance, I'm going to have to know the starting value. So we'll use an S for starting value, which is $450. And I also have to know my interest. So we'll use I for interest. And interest is going to be found by doing 12% of the amount of money she has in her account. So we're going to do 12% of $450. Okay, so to find my total balance, I'm going to have to take my starting value and add my interest to that. And my starting value is $450. So my total balance is going to be $450 plus my interest. And my interest, we said, was 12% of $450. And there's one of those words that means multiplication. So in order to find my interest, I'm going to have to do 12% times 450. But first we're going to change our percent to a decimal. So we move our decimal 2 places to the left. So we get 12 hundredths times 450 as our interest. And 12 hundredths times 450 is 54. So our amount of interest that we earned in that month was $54. Therefore, our total amount is $450 plus $54. And then we just add those two amounts together. Therefore, our total amount is $504. And that's how much money we have after 1 month. Word problems and subtraction. When you read a word problem and you see words like difference, less than, decreased by, or fewer, then you know you're going to need to subtract. Let's look at an example. 6 less than a number is 8. What is the number? Since they're asking us what the number is, that means we don't know it. And if we don't know a number, then we use a variable for it. So right here where we see a number, I'm going to put a variable. I'm going to use x. This phrase less than tells us that we need to subtract. So we have 6. We're subtracting. We've got a number. Is an equal sign 8. But less than is a tricky phrase. It does mean to subtract, but again, you have to reverse the order of the things you're subtracting. Like if I said, I have $5 less than Jimmy has. That means that Jimmy has more money than I do. So I'd have to do Jimmy's money minus $5 in order to find out how much money I had. So 6 less than x is going to be x minus 6 is equal to 8. So what number would I subtract 6 from to get 8? That number is 14, so that means x is 14. Now, if you didn't know that the number was 14, then you could solve this algebraically by adding 6 to both sides. So you'd have, again, x equals 14 because 8 plus 6 is 14.